Welcome to Course Materials YouTube channel. In this video, we will discuss how to integrate renewable energy into power grids and the various possible challenges and solutions. The world is facing a climate crisis, and we need to reduce our dependence on fossil fuels for energy. Renewable energy sources, such as solar, wind, and hydro, offer a clean and sustainable way to power our lives, but they also pose some unique challenges for integrating them into existing power grids. How can we ensure a stable, reliable, and resilient grid that can handle the variability of renewables? In this article, we will explore some of the technological and non-technological solutions that can help us achieve this goal. The intermittency dilemma. One of the main challenges of integrating renewables into the grid is their intermittency. Unlike coal or gas plants that can produce a steady and predictable amount of energy, renewable energy outputs depend on weather conditions. For example, solar panels produce more energy on sunny days than on cloudy days, and wind turbines generate more power when the wind is strong than when it is calm. This means that the supply of renewable energy can fluctuate significantly, creating imbalances in the grid that can affect its stability and reliability. To address this challenge, we need to find ways to balance the supply and demand of energy and to cope with the sudden changes in renewable energy production. Some of the possible solutions are: technological solutions. Smart grids. A smart grid is a grid that can monitor, control, and optimize the flow of energy using advanced sensors, data analytics, and automation. A smart grid can anticipate the fluctuations in renewable energy production and demand, and adjust the dispatch of other energy sources accordingly. A smart grid can also integrate distributed energy resources, such as rooftop solar panels or electric vehicles, into the system and enable bidirectional communication and power flow between the grid and the consumers. Energy storage. Energy storage is a technology that can store excess renewable energy when it is abundant and release it back to the grid when it is needed. Energy storage can smooth out the supply curve of renewable energy and provide backup power during peak demand or grid emergencies. Some examples of energy storage technologies are batteries, pumped hydro, flywheels, and compressed air. Grid modernization. Grid modernization is the process of upgrading and improving the existing grid infrastructure to make it more compatible and flexible with renewable energy sources. Some of the steps involved in grid modernization are enhancing the transmission and distribution lines to reduce losses and increase capacity, investing in flexible generation sources such as natural gas plants or demand response that can ramp up or down quickly to balance the grid, and diversifying the renewable energy portfolio across different locations and technologies to reduce the risk of simultaneous outages. Non-technological solutions. Policy frameworks. Policy frameworks are the rules and regulations that govern the energy sector and influence the development and integration of renewable energy sources. Policy frameworks can support the integration of renewables by providing incentives, such as feed-in tariffs or carbon pricing, that encourage investment in renewable energy projects and discourage fossil fuel consumption. Policy frameworks can also set standards and targets for renewable energy penetration and grid integration and facilitate the coordination and cooperation among different stakeholders, such as utilities, regulators, and consumers. Consumer engagement. Consumer engagement is the involvement and participation of energy consumers in the energy system and the grid integration process. Consumer engagement can empower consumers to make informed and responsible choices about their energy consumption and production and to contribute to the grid stability and reliability. Some of the ways to engage consumers are providing smart meters and real-time feedback on energy usage and prices, offering demand response programs that reward consumers for reducing or shifting their energy demand during peak periods or grid stress, and enabling peer-to-peer energy trading and sharing among consumers with distributed energy resources. International collaboration. International collaboration is the exchange and sharing of knowledge and best practices among different countries and regions on renewable energy development and integration. International collaboration can accelerate the adoption and innovation of renewable energy technologies and solutions and overcome the technical and institutional barriers that hinder the integration of renewables into the grid. Some of the platforms and initiatives that facilitate international collaboration are the International Renewable Energy Agency, IRENA, the International Energy Agency, IA, and the Clean Energy Ministerial, CM. Integrating renewable energy into the grid is a complex and multifaceted challenge that requires a holistic and systemic approach. It is not only a technical problem, but also a social, economic, and political one. It demands innovation, collaboration, and commitment from all the actors involved in the energy system, from the producers to the consumers, and from the local to the global level. By addressing this challenge, we can create a cleaner, more resilient, and more secure energy future for ourselves and for generations to come. What are your thoughts on integrating renewable energy into the grid? What challenges and opportunities do you see? Share your perspective in the comments below. Let's keep the conversation going and power up the future together. Thank you for watching this video. Please subscribe to this course materials YouTube channel to stay up to date with more of our educational videos.